right, 6.12 is all about wind energy. And so, wind energy is just the kinetic energy of moving air, which we call wind, which spins a turbine. This all sounds familiar. I've been talking about this for everything, but it spins a turbine, which turns a generator. And then that mechanical energy inside the generator turns into electrical energy with the use of an electromagnet, and then that electromagnet sends the energy out to a transformer, which transforms the energy into, takes it from the um, wind turbine and sends it out into the electrical grid. So let's talk about what that exactly looks like. So here is the wind power coming in. The turbine in this case is this right here. It's the fan, the blades that we see. And then that is connected to, and that is going to be then the mechanical energy that is going to turn into electrical energy within this generator due to that spinning electromagnet. And then that's going to go to this power interface, which is basically the same thing as a transformer, like we've talked about, which then goes into the electrical grid. Okay. And so the average turbine, so one wind turbine, which is, the blades that we see, can power 460 homes. And that's on average, because it all depends on the amount of wind that you're receiving. So it has 15 to 30% capacity factor, which what that means is a percentage of the total possible energy it could generate. It only produces electricity in 8 to 55-mile-an-hour winds. If it gets much faster than that, it can actually damage the turbine. And then if it is slower, it's not generating enough, kinetic energy to actually power the generator. So that's a problem. Okay. So um, that's a limitation, I guess, of having wind, being able to use wind energy everywhere. So there is a motorized drive within the shaft, which can turn the turbine to face the wind so that it reaches the speeds that it needs. So that's good. That's a nice little feature that we find within wind turbines. Wind turbines tend to be clustered in groups of anywhere from from a couple to several, up to like huge wind projects or farms like we see in off of I-65 heading towards Chicago around the West Lafayette area, around Purdue University, and they tend to be in flat open areas. Usually those are rural areas. Sometimes they're often along coastlines or just offshore, out in the ocean a little bit, along the shorelines. So that tends to be where we find them. They need to be like kind of keeping them clustered together makes them easier to service, because you can imagine if there's just one out there by itself, it's not going to be very cost effective to send a crew out to actually do the work to either service them, repair them, or build the transmission lines to collect the electricity. So they tend to be clustered together. They can share land with agricultural use, which is a really nice feature. That's why we tend to see them in fields. And then farmers can actually reap the benefits of renting their land for the wind turbine. That's kind of nice for the farmer as well. It's kind of a win-win in that scenario. Offshore winds tend to use, like I said, oceans or lakes. And that is a good thing because around water, we tend to have faster winds, so they can actually capitalize on that. It does require those transmission lines, though, to be built across long distances to reach land. And so that's a drawback of that. So here are the benefits of wind power. They're non-depletable. The wind is always around, so that's even better than renewable. We're always going to have wind. It's not decreased by use, so that's a win-win, kind of like solar energy. There's no greenhouse gas emissions or air pollutants released when we generate the electricity. That's a positive. There's no CO2 or NOx, SOx, or PM. So that's actually better than other resources because we still had some CO2 that was being produced with other resources. They can share land, so it doesn't necessarily destroy habitat, but there have been some studies that shows that it interferes with either migrations or the noise actually creates some noise pollution, which there's starting to be some studies showing that that could interrupt breeding habits of organisms and breeding habitats. So that could be a potential unintended consequence that we're noticing. And it doesn't cause soil or water contamination like fossil fuels do. So that's a benefit. Some drawbacks, there's intermittency issues. So the wind isn't always there, right? Even in windy locations, it's not 100% of the time there. So just like sunlight, there's that intermittency problem. And it can't replace baseload power sources like fossil fuels and nuclear and geothermal sources. It can't replace baseload power sources that are always available. So we talked about that, and that's mentioned twice. I don't, oh, because it goes with the one benefit, there's a drawback. I see. And then it can kill birds and bats, especially larger migratory birds. They can get hit by those turbines spinning. That's not like a major issue, but it does happen. So that, it is a problem. And then it is considered an eyesore. It doesn't look great if you have it, your house is sitting underneath one of those things. And it does create noise. So they do tend to keep them away from homes. So it does then take up land that we could use to build homes on. And it does create some noise pollution, like I said. And so we're kind of still, figuring out how that's impacting organisms. And so we're already to our practice FRQ, so that's good. So explain an environmental benefit a town might experience if it switches from a coal-fired power plant to a wind farm as its primary source of energy. I would also challenge you to explain a drawback that the town would also experience as it switches from a coal-fired power plant to a wind farm. So do both a benefit and a drawback. Okay, I'll see you guys next time.